I'd like to present my work perspective generation via multi-head attention mechanism and common sense knowledge. So before we go deep in our work, I'm going to present some motivation behind our work. So first, the consideration of multiple viewpoints on controversial issues is critical for avoiding bias. Bias, which is a problem in dataset. Bias problem that the model has less performance to generalize. So we need to reduce or to alleviate this problem. Also, multiple viewpoints or perspectives assist in formulation of rational decisions. We observe that the current model imposes constraints on diversity and equality. This is because the conventional attention mechanism is biased toward a single semantic aspect of the claim, whereas the claim may contain multiple semantic aspects. Additionally, ignoring common sense knowledge may result in generating perspectives that may violate known facts about them. So, the main objectives of our work, the purpose of our work is to examine the question that can we generate high quality, multiple relevant candidate perspectives for a given claim. So the input of our model is the claim. Our proposed model employs multi-generator to generate different perspectives. We also developed the ability to generate multiple perspectives from its input, which is a claim. The meaning by claim is the argumentative sentence. And to optimize our model, we use the reward function as an evaluator. As a result, we begin by introducing another technique for generating diverse and high-quality perspectives by focusing on various semantic aspects. Then, after we apply the semantic aspect using multi-head attention mechanism, the generated perspective, which is output from this model, are then supplemented with a collection of common sense facts. So, as we said before, common sense facts could help us in order to keep the well-known facts in the world and in order not to violate those facts. Also, we apply different reward functions using reinforcement learning we combine multiple learning objectives for model training. So, our primary contributions are summarized in this slide. In this work, we propose a novel approach for perspective generations. Given a specific claim about controversial issues. We mean by controversial issues, there are a lot of evidence or perspective toward this issue. We want to construct a logical set of perspectives with varying stances. Rather than generate a perspective based on single semantic aspect as traditional approach. So, in traditional approach, the attention mechanism could let the decoder or the generator to focus only on one semantic aspect. For example, if we have one sentence talk about different aspects, so a traditional mechanism, attention mechanism, has only one semantic to be focused on, while multi-head attention mechanism could generate different diverse perspectives based on different semantic aspects. Also, as we said before, common sense will be incorporated to ensure the model doesn't violate or the output of the generated perspectives aren't violate the known facts about the world and to improve the quality of generated perspectives. We also employ reward function. We mean by reward function, we have different function could guide the generation process for our model. Multi-objective reinforcement learning will be used to produce various scores, ensuring that generated perspectives make appropriate use of the given context and allowing control of the text generation model without relying on single objective during the decoding process. Experiments show that our model outperforms several existing sequence-based perspective model on equality and diversity methods. So here in this table, we show an example for perspective generation. We have a claim, which is a government should lessen the economic gap between its rich and poor citizens. So this claim is the input, the only input of our model, and we will try to generate different perspectives. Each perspective could focus on a semantic aspect. We mean by semantic aspect is a feature or information in the claim that could be focused on, and this perspective should have a stance, a particular stance, either support or attack. So the difference or the main difference, the difference between any sentence and the perspective sentence is the perspective focus on a semantic aspect and has a particular stance towards the claim. So here we will show our proposed model. To begin, given a claim and some random word replaced with synonyms, our generator is contextualized and more diverse thanks to the wordnet corpus. So we will use wordnet corpus in order to replace some words in the claim in order to get more diversity of our output. Then after the wordnet is applied, multiple semantic aspects are extracted. As we said before, the semantic aspects could be extracted using multi-head attention mechanism, and in order to obtain the claim representation. So the modified version of the claim with a new replaced synonyms word of the claim with and also with the semantic extracted aspect are used to guide the generation process in order to generate a candidate perspective for each semantic aspect. So suppose that we have 8 semantic aspects that have been extracted by the multi-head attention mechanism, then we could get 8 candidate perspectives. After that, for more information and better equality perspective, our model takes common sense into account. We use reinforcement learning to enforce diversity, stylistic, and quality constraints on the generated perspective. The overall architecture of our proposed model is shown in this figure. So here, the general architecture for our model. We begin with the input. The input is a claim. So claim is a statement or argumentative statement that has a particular stance toward any evidence. So we begin by randomly replace synonym word. The main objective of replacing with the synonyms word is to get more diverse perspectives during the generation process. So we then encode our the replaced claim with those synonyms words, and then apply the multi-head attention as in the blue-black box here. Then we will get different context vectors of each head. So as we supposed before, suppose that we have 8 or we use eight heads. So then we will get eight of context vectors. The previous attention mechanism produced only one context vector. So in order to get more diverse perspectives, as in this example, we could get eight perspectives. So so the output is generated perspectives. In order to optimize our model, we use reward function. As we said before, the reinforcement learning is used for optimize our model. So different reward function will be used, and I will explain them in the next slides. After we reward and get the final candidate perspectives, we will apply paracomet. Paracomet is a model that could provide different common sense for our model in order to keep and not violate the common sense or the well-known facts in our world. So we use after we get more information, which is common sense, we apply two encoders. And in application study, we will explain which is better. The first decoder is the last hidden state average, and the second decoder is the fusion decoder. So the more high quality perspective is get, and also the reward function is used for more for optimize and for training our model. So our model has, as we said, has two modules. The first, or two stages. The first stage is semantic aspect will be considered during the generation process. So, as we said, the revised version of the claim includes a new substitution synonym. The modified version of the claim is created by replacing specific words in the claim input with synonyms at random. The claim's word sequence is used as input, with specific word being replaced by synonym at 60% ratio that fits the semantic aspect context. So, inspired by multi-head attention with sequence-to-sequence models, this work employs mechanism to enable the generator to attend information from different representation subspaces. The traditional attention mechanism only lets the decoder to attend to information from only one subspaces, So the multi-head attention gives us more context vectors during the generation process. With these context vectors obtained by multi-head attention mechanism, different semantic aspects could be focused. So for each head, a single semantic aspect, we will get a particular text. So the context vector of each head, we mean by each head, as we said, multi-head, we have different heads. Each head can then be produced by multiplying the encoder hidden state by weighted sum of all semantic spaces. So the attention process is used to obtain numerous attention probability distribution over the claim ones. So in the second stage, we will apply the common sense knowledge in order to maintain higher quality perspective. In the previous work, we see that, or we have noticed that most of the perspectives, the generated perspective, don't consider the common sense. So, for example, if we said that apple is a fruit, the model could violate this and this known or knowledge, and consider the apple as the vegetable. So additional inferences based on common sense can be formed from a claim accompanied by a modified claim. hence improving the quality of generated perspective. To incorporate common sense inferences in our model, we rely on paracomet model. We have two sentences and a modified claim with random replacement where we feed all of these as input to the trained paracomet. Paracomet is a pre-trained model. It's open source and we could use it, would generate 9 common sense relations for both sentences. We tried different models that consider common sense, aiming at enhancing the quality of generated text. The first, so we now use different enhancer in order to keep going, in order to get more or better quality generated perspective. The first enhancer model averages the last hidden state for all related common sense to the I perspective and update the context. The second enhancer model makes use of a fusion decoder that is supplemented with common sense sentences retrieved from the external model. So the first model or the first enhancer, each agent, we mean by agent is the generator take the encoded information from the encoder, which represents a particular generated perspective from the first stage. It considers other agents' information common sense relation by averaging the last hidden state of other encoder to produce more important information. So the attention vector is produced by considering the encoded feature, also the previous encoder state, in addition to the context vector. Finally, the context vector updated based on attention distribution. Then we will apply the pointer attention method as in the past. Regarding the second enhancer or the suggested enhancer for our model, we use fusion encoder, which is the existing model, and it is a sequence-to-sequence model that accepts as input previously generated perspective and a set of common sense from paracomet. It produces high-quality work that's added to accepted word path. Given a perspective with common sense and -1 common sense in support, each common sense is concatenated with the perspective to produce perspectives common sense context. Where here we mean by FI the encoded feature of the produced or the represented information. So, in order to optimize our model, our algorithm attempts to provide a very diverse and high quality perspective with distinct stance. We mean by stances a particular stance or position towards the claim, either attack or support. So we use a composite score generated by averaging the specific measures to generate text under various conditions. The average of individual matrices include road, textual entailment, style control reward, and style control reward and stance control reward. In addition to diversity with fluency, we can provide a normalized score between 0 and 1. So I will explain each of these reward functions correctly. So we will start by road, which is very known and well known for different natural language processing methods like text summarization. So the road to compare the degree of to which the generated perspective retains context, it's rewarded using the road backdated primary. So we have 3 matrices of road 1, road 2, and road L. The road L1 focus on unigram overlap, while road 2 the bigram overlap. So the overlap could be measured between the reference and the our generated perspective, and Roj L is the longest common subsequent between the reference and the reference perspective and the generated perspective. Text entailment. So if we have generated perspective, we try to evaluate to which extent the generated perspective is entailed by the reference perspective. We apply the style control reward. We try to we feed the generated with additional style embedding, and we can conclude can calculate the probability of the output conditions based on the style control variable. The reward that is convolutional neural. So here the style control reward is a convolutional neural network that has been trained to minimize cross entropy loss in style classification. So that the classifier is a convolutional neural network that could give us classification if the generated perspective preserve the style or the preferred style or not. These stance, as we said, there is difference between any general statement with a perspective. The statement perspective should focus or should have a particular stance toward the claim, so we can calculate the probability of the output condition based on the stance control variable by feeding the generator with additional stance embedding. So suppose that we want our model to generate a perspective with attack stance. So we should provide additional stance with attack information to our model. Finally, we will try to preserve or to guide the decoder to generate following perspective. So it demonstrates the naturalness of generated perspectives by measuring the grammatical correctness to increase the probability of target sentence being used. So we apply the perplexity, which is generally used in different processing tasks for preserving the fluency. We propose to use GB2, a large scale pre-trained language for fluency, which is suitable for likelihood-based fluency evaluation, conditional and conditional generation. Also, we have expression diversity. As we said, we have two matrices we focus on in order to optimize our model: the diversity and the quality. For diversity, there are a lot of matrices that could use in order to like the blue, which is to assess the diversity, high score indicating greater diversity. It's calculated the blue score for each generated perspectives, and then the averaging blue score for generated could get us the final output of diversity. In order for experiment and the result, we apply or we use perspectrum dataset. Here in this figure, we show how perspectrum dataset is annotated. So it's begin with a claim, as we can see here. Animals should have lawful rights, which is the claim, and there are a lot of evidence paragraphs that substantiate with this claim, either attack or support. So for this claim, there are a pool or a set of perspective sentences with different stances toward the claim. So here in the green box, we could see animals are equal to human beings, which has strongly supported the claim. And regarding the pink box, we can see the perspectives with oppose or attack stances toward the claim. So we use this data set for training and testing our model. Here we can show the experiment and result for our model. For evaluation, we compare with the state art model, which is BARC, which their model has been trained using the same data set. So, but this model as but baseline doesn't use multi-head attention mechanism, and it doesn't use the common sense knowledge. Also, their model is optimized using cross entropy, while our model is optimized using the reinforcement reward function to improve the quality and the diversity of our. Here I will show an application study in order to check the applicability and the value of using different techniques in our model. So we start by pointer attention only on one semantic aspect. As we said, only one semantic aspect is used in traditional attention mechanism. Then we use various semantic aspects. ArcDiver is the baseline that we use in order to compare our performance with this model. In the second step, as we said, we use the common sense. Here we use the fusion decoder, and here we use the average of last state. So we can see the best result is using the multi-head attention with common sense and optimization by the reinforcement learning as in the last row. So we get better blue result embedding average, and we use the same matrices that have been used in PARC model, which is the baseline that we rely on in order to evaluate the performance of our model. So this table shows the quality matrices. The second table in the second slide show the diversity of our model. Also, we use the application study in order to check the applicability or the how much our proposed technique could be improve the diversity and the quality of the generated perspectives. Also, we can see common use with multi-head attention mechanism rewarded by reinforcement learning functions could get the best results. So we investigate our models in this section, and the application findings are summarized as in the table that I have shown now. So as we said, the common sense with multi-head attention and focusing on different semantic aspects rewarded by reinforcement learning functions could improve the performance of our model in terms of the quality and diversity matrices. Okay, experiment and findings reveal that the reinforcement learning is capable of effectively learning to generate diverse and high quality peripheral and it greatly increases the generation quality when compared to the nearest state-of-art system. To conclude, this work discussed the generation of perspectives via the employment of several heads of attention to analyze various semantic aspects of the claim. Additionally, we addressed how to maximize the benefit of utilizing various common sense pieces of information. So finally, our approach is capable of generating more and better quality and diversity of different viewpoints of view. we conclude that the reward function advances the state of the art in perspective generation by giving different signals to guide the generation of process. The result demonstrates that the reinforcement learning is significantly more performance than the state of our perspective generation model when considering different semantic aspects and encoding our comments. Thank you very much. So anyone have a question? Yes.
Thank you. Thank you very much for your wonderful presentation. It's a great one.
Thank you.
And does anyone have any question? Does anyone have any question to Fatima? Yep. Thank you, Fatima. Again, it's a wonderful talk. Is there any limitation in your work?
Yeah, the limitation is the data set is a small size, and so I need a bigger data set. That could be, deep learning model needs a lot of annotated and labeled data for training. So I think the size of the available data set is a challenge.
Yep. Thank you. Thank you very much. It's wonderful.
Thank you very much.